So in this tutorial we are going to learn some more examples of linear programming problem. So let us look on to this example. A truck company requires the following number of drivers for its trucks during 24 hours. The time allocation is given for from 0 to 4. It will be like 5 persons were required or 5 drivers were required. So similarly from 4 to 8, 10, 8 to 12, 20, 12 to 16, 12, 16 to 20, 22, 20 to 24, 8. According to the shift schedule, a driver may join for the duty at the midnight 4, 8, 12, 16, 20 hours and work continuously for 8 hours and formulate the problem as linear programming problem to get the optimal shift. So if you get any keyword like an optimal shift, then the problem is said to be a minimization problem. And to solve this kind of problem, we have to see the number of hours the workers or the drivers works continuously. Here the continuous hour they have to work is 8. So we should not take this as x1. So what we have to do is so we have to use this 8 hours. So 0 to 4 it will be like 4 hour and 4 to 8 it will be like 8 hour. So we have to create an equation like this x1 for the first 8 hour plus, so they can continue to the work from 4 to 8 or 8 to 12. So they can write like this x2 x1 plus x2 greater than or equal to 10. Since the problem is minimization, so the problem is x1 plus x2 greater than or equal to 10. So to write this equation or to write the constraint for this time limit, we have to write x2 plus x3 greater than or equal to 20. So similarly for this one 12 to 16 we can write x3 plus x4 greater than or equal to 12. For this 16 to 20 we can write x4 plus x5 greater than or equal to 22. For this 20 to 25 we can write x5 plus x6 greater than or equal to 8, like that we can write. So for this obviously it is like x6 plus x1 greater than or equal to 5. So I have not written for this constraint, so just write it yourself. So x6 plus x1 greater than or equal to 5. For this constraint it will be like x3 plus x4 greater than or equal to 12, x4 plus x5 greater than or equal to 20, x5 plus x6 greater than or equal to 8. Then what about the objective function? Z is nothing but we have to add all the time, because the time slot is given like 4, 8, 12, 16, 20 hours. So it will be like Z is equal to x1 plus x2 plus x3 plus x4 plus x5 plus x6. So it is like x1 plus x2 plus x2 plus x3 plus x4 plus x5 plus x6. The problem is minimization problem. So we will look on to the similar example. So the same thing, a city hospital has following minimal daily requirement of nurses. The period is given and the clock time is given and minimum number of nurses required. So if the problem comes like minimal, the problem is said to be a minimization problem, and the report they asked to work for 8 continuously hours. So from 6 to 10 it is like only 4 hours. From 4 to 12 it is like 4 hours. So what we can do is we can write the second equation like x1 plus x2 greater than or equal to 7, and this as x2 plus x3 greater than or equal to 15, and this as x3 plus x4 greater than or equal to 8, and this as like x4 plus x5 greater than or equal to 20, this as x5 plus x6 greater than or equal to 6, and the starting value like 6 a.m. to 10 a.m. we can write like x6 plus x1 greater than or equal to 2. The objective function, you have to get the summation of all the values like x1 plus x2 plus x3 plus x4 plus x5 plus x6. Similarly, so this will be the final solution. We have to write like this, and with help with non-negativity constraint x2, x1, x3, x4, x5 is x6 are strictly greater than or equal to 0. So we will see another problem. A farm is engaged in breeding pigs. The pigs are fed on various products grown up on farms. Because of the need of ensure certain nutrient constituents, it is necessary to buy additional one or two products which we shall call A and B. The nutrient constituents in each units of the products are given below. So the problem itself they are given in the form of table. So the problem is minimum amount of nutrient is required. So it is the problem is minimization problem, and the profit is also given 20 per unit, and B for cost per B is 40. So this will be the objective function, and this will be the constraint. 36 xa plus 6 xb greater than or equal to 108, 3 xa plus 12 xb greater than or equal to 36, 20 xa plus 10 xb greater than or equal to 100, and x1 sorry xa comma xb should be strictly greater than or equal to 0. That is non-negativity constraint. And we have some other problem, so you can work it out with yourself. So you can pause the video and you can understand the problem, and you can see the solution, or you can obtain the solution. So this will be the solution for this problem. So you can pause the video and you can check out the solution with yourself. So this is another problem. So here they are producing two styles of shirts, style 1 and style 2. So this will be the solution. So you have to write like this. For example, when you take x1 as a variable for style 1, you have to take x1 equal to number. You have to write x1 equal to number of style 1 shirts. Similarly, x2 is equal to number of style 2 shirts. So the problem is here they have given us to maximize. So the problem is maximization problem, and the constraint is also given. What they have given in the grams, but the net profit like 19.50 for style 1 and 15.90 for style 2. So it will be a like objective function, and it has an inventory of 24 kg of cotton thread, 26 kg of decon thread. So what you have to see is here they have given everything in grams, but here they have given everything in kilograms. What you need to do is you need to convert that kilogram into a gram, because in the left hand side they have given everything in a gram. So right hand side, if kilogram is given